Hello students, this is lesson U4A02c. By the end of the lesson you should be able to say I can use properties of sides and angles and diagonals to identify a parallelogram in a geometric proof. So ladies and gentlemen, I encourage you to pause the video and to actually write down what are the five properties that make a quadrilateral a parallelogram before we continue in this lesson, because it is important for you to have that information internalized. And if you don't have it internalized yet, I encourage you to go find the notes necessary for this lesson. So go ahead. So welcome back. Hopefully everyone here got the chance to look that information up or was able to write that information down. So the first idea was opposite sides are congruent. Opposite sides are parallel. Opposite angles are congruent. We have at least one pair of sides parallel and congruent. And the fifth, last but not least, diagonals bisect each other. These are the five properties that make a quadrilateral a parallelogram, and we are going to be maximizing our understanding through the use of these properties in today's lesson. So let's take a look. I encourage you again to pause the video to see if you can figure out this proof on your own. I encourage you to again draw the diagram and create the statement of reason chart. Draw all over the diagram before approaching this proof. So hopefully you had some time to think about this, okay? You're given that two pairs of triangles are congruent. So we have triangle ABE is congruent to CED. Notice that here we have, we have these two triangles are also congruent to one another, right? So thereby making these two triangles should be congruent to one another. But anyway, with that mentioned, okay, let's just go through and analyze some of the information that we can extract from this. So knowing that a side length AB, I'm going to use another color here. So I know that side length AB will be the same as side length CE. So I'm going to use AB and CE will have the same length. I'm going to use highlighter to highlight this. And then I have side length BE will be the same length as side length ED. So I'm going to use another color. I'm going to use red. So BE will be the same length as ED, which is this length right here. And lastly, side length AE will be the same length as side length CD. And with that, I'm going to use the color green. So this will be the same as that. Okay, so those are all the corresponding sides, okay, that are going to be congruent. If I take a look at the next line right here, which line 2, which says that CED, triangle CED, is the same as triangle CEB. Notice right now, side length CD, which is this guy right here, side length CD, should be the same as which corresponding side in triangle CEB? It should be the same as side length CB. So with that said, what color should I be highlighting side length CB? CB should be highlighted in green. So therefore, CB here should be highlighted in green. Can you take a look at quadrilateral ABCE and tell me whether or not this is in fact a parallelogram or not? As it turns out, it is. Which property are we going to be utilizing? Is it going to be opposite sides congruent, parallel, or opposite angles congruent? It looks to be that opposite sides are going to be congruent. So therefore, we just walked through talking about this proof. And now let's just try to put it into words, okay? So one of the first things that we did, okay, is we try to link the two triangles to one another. I took a slightly different approach, which, by the way, I'm just going to let you take a look at this. I took a slightly different approach. What which is fine, okay? This goes to show that not a single technique or a not single approach is always going to be like the way, okay? So this is a little slightly different from what I had originally intended. So I'm going to go with this. So I'm going to tell you, okay, one of the first things that we did was we identified, okay, side lengths that are the same. So I know that AB is congruent to CE. And this is because of CPCTC, right? Corresponding parts of congruent triangles are congruent. I also recognize that CED, right? So I also recognize that BC is congruent to CD. I'm sorry, CD is congruent to CB because of, again, CPCTC. I also recognize that AE is congruent to CD because of, again, CPCTC. So if you look at this, okay, we have all this information right now. We have AB is congruent to CE and CD is congruent to CB. A lot of things are happening. If you look at this, right, I can immediately say that, oh, therefore AE is congruent to CB because of substitution. Between which lines? I am substituting information from line 4 and line 5. And then last but not least, I can say, because I have one pair of sides that are opposite and congruent, and I have another pair of sides that are opposite and congruent, so therefore I can say ABCE is a parallelogram. Because opposite sides are congruent. So I took a slightly different approach, okay, while I'm going through this live with you guys, but that's okay. This, again, goes to show there are more than one way. There are multiple ways of proving something. You do not have to rely on this. What is the approach that I had taken? I first made a substitution between these two triangles, and that is perfectly fine, right? I'm substituting line 1 and line 2. And then having that declaration, we can then go through and say that AB and CE are going to be congruent because of CPCTC. We can also declare that BC is going to be congruent to AE. BC is going to be congruent to AE, okay? Because of, again, CPCTC. And last but not least, okay, we can then say that ABCE is a parallelogram because opposite sides are congruent. So this one here, this approach that I had taken before, okay, is slightly more efficient. However, again, just goes to show, we are not limited to just one approach. Let's take a look at another example. And again, I encourage you to pause the video and try this on your own. So hopefully you guys had some time to think about this. So what we have here is angle B is congruent to angle D, and then angle BAC is congruent to angle DCA. Okay. So what we want to do is we want to go through and prove why ABCD is in fact a parallelogram. Let's go through and try this. So, and again, mark the diagram up. So we know that B is congruent to D. And we know that BAC is congruent to DCA. So wait a minute. I'm sorry, I mislabeled DCA. So wait a minute. If I know that those two sides are congruent, or actually not sides are congruent, those two angles are congruent. When I say those two, I mean these two are congruent, okay? We can immediately justify that certain side lengths are going to be parallel to one another, right? So we can immediately justify that these two side lengths in red are going to be parallel to one another. Why? Because we have, in line 2, those are alternate interior angles. And if those are alternate interior angles and those two sides are parallel, okay, and I also recognize that I have AC here is congruent to itself, I can immediately say that triangle ABC is going to be congruent to triangle CDA because of angle side. And then lastly, I can say that AB is congruent to DC because of CPCTC. Anyway, we can go through all that, and then we can, you'll see that it's actually, we need to prove that the triangles are going to be congruent to one another, and then we can use one of the 5 properties to show why this is a parallelogram. So I know that AC is going to be congruent to itself because of reflexive. So because of that, we can then declare that the two triangles are going to be congruent to one another because of angle side. And because the two triangles are congruent to one another because of angle side, we can then say that certain parts of the two triangles are going to be congruent. So we can say that AB is going to be congruent to CD because of CPCTC. We can also declare that AB is going to be parallel to CD because from line 2 here, we have alternate interior angles. So therefore, AB and CD are both parallel and congruent. So if we have one pair of sides that are both parallel and congruent, that is actually enough information for us to declare that ABCD is in fact a parallelogram, because we have one pair of sides parallel and congruent. Could you have approached this slightly differently? Of course, okay? We could have approached this by declaring, after knowing that these two triangles are congruent, okay, we could have continued saying that AD is congruent to BC. And then we can use opposite sides are congruent to show that this is in fact a parallelogram. But then this is, I wanted to show you an alternate approach. And that's it.